This is a video on probability with a focus on expected value. So first of all, just a little bit of notation. We can write expected value as EX. Other notation that we're going to encounter in this video will be PX, which we're familiar with from before. It just represents the probability of an event. And we're also going to encounter sigma, which is an instruction to add values together. Sometimes it's called summation. We're going to be using a formula in this video, and the formula is the formula for expected value. And the formula for expected value is summation x times probability of x. So in summary, the expected value formula tells us to add up all the values of x multiplied by their probabilities. Before we go to actually do any calculations here, let's also just have a think for a moment about what actually is expected value. What do we mean by EX? What we mean by EX is the long run average outcome. And in probability, when we say long run, we really mean long run. We mean if we were to repeat our experiment an infinite number of times and then take all that information and get an average, that's what the expected value is. Now, obviously, on a practical basis, we can't actually do that, but probability allows us a way in to do this calculation. So let's have a look at an example. So my example is I roll a dice and I want to find the expected value. So to find my expected value, I'll have to take my values of x and then multiply them by the probabilities. Now, x is just my different outcomes. So when you think about a dice, you can see that there's 6 different outcomes that I can possibly get, which are just the different sides of the dice. So the first thing that I'm going to do is make a list of those. And generally, when dealing with expected value, that is a good idea to actually make a list of the outcomes and even present them in a table. And that's how I'm going to present my answers in this video. So when I say x here, it's all the different outcomes I can get. And of course, the outcomes of the dice, like we just discussed, are 1, 2, 3, 4, 5, and 6. Next, I want to note the probability of each of these individual events. Well, of course, I'm rolling a dice, so the chances of getting any one of the individual sides is 1 in 6. So that's very easy in this case. Now, next, if I look at my formula, what it's telling me to do is to multiply my value of x by its probability. So I'm going to take each value from the x column and multiply it by the probability that it goes with. So this is the stage at which I'm doing x times px. So here are my calculations for that. And then finally, the formula tells me that I want to add all of these up. So I'm going to total up this column and I get a total of 3.5. And this 3.5 is my expected value. Sometimes the question will be as simple as this, where we have numerical outcomes for an event and we want to find the long run average of those outcomes. But sometimes we'll have examples or questions where we have an amount of money assigned to a particular outcome, maybe winnings or losses that might occur depending on different outcomes. And this is a fairly common type of question that we'll encounter in expected value. So let's have a look now at an example of one. So in this example, we're sticking with the dice, but we're changing the way the question is worded a little bit. I'm playing a game where I roll a dice. If I get an even number, I win €2. If I get a 1 or a 3, I lose €3. And if I get a 5, I win a fiver. And I want to know what is the expected value. So I'm going to take a similar approach to before, in that I'm going to make a table out, and my headings of the table will be the same as last time. They're going to be x, px, then multiply, and then total them up. But just before I begin to fill anything in, remember what I'm really focusing on here is the money that I'm going to win. So the outcomes that I'm focusing on are the financial outcomes, if you like. So it's important that I'm not just filling in 1, 2, 3, 4, 5, 6 here, but how much money I would win or lose in each circumstance. Just to help me out and have a little guide, if you like, I'm going to list out what the outcomes are on the face of the dice. They won't be involved in my calculations. They're just to kind of help me keep on track with what I'm filling in. And what I'm really going to fill in for x is what I win or lose for each individual outcome on the dice. So I know that if I get an even number, I win €2. And since I've got options to win or lose, I'm going to put in +2 for these because I'm winning this €2. Then, of course, if I roll a 1 or a 3, I lose €3. So I'm going to assign this a negative value then, so -3. And then if I roll a 5, I win 5. So we'll give that plus 5 as its value. Now, just to note at this point, I've done all my values individually for the dice, but you could group the even numbers together and say plus 2, and then that obviously would affect the probability of that set of outcomes, because getting an even number has a probability of a half. I've split it up into the individual actual outcomes here, so just be aware of that. So each of these individual outcomes has a 1 in 6 chance of happening, and now I'm going to multiply the outcome by the probability. So I've multiplied the outcome by the probability in each case. Notice that I've left them all in fraction form just to make it easier for myself to add up and also to avoid having to round off with any decimals. And now to finish it off, I'm going to add these values together. And when I add them in this case, I get 5 over 6. And this is my expected value. Note that it's a positive value, so on average, in the long run, I'd expect to win this much. Note also that it's an amount of money, so I'd never really say 5 over 6 euro. So in this case, I'm going to write this in decimal form and round it to the nearest cent. So in this case, my expected value is 0.83. Another way of saying this is that if I was to play this game repeatedly, in the long run, and again, when we say long run probability, we really mean the long run, I'd expect to win on average 0.83 euro. The idea of winning or losing money ties into the idea of fairness, and sometimes we get asked with expected value whether a situation is fair or not. So let's look at an example now involving that. So here's our example. I play a game where I paid €2 to roll a dice. If I roll a prime number, I get €1. If I roll a 1, I get nothing. If I roll a 6, I get €6. And if I roll a 4, I get €2. And I want to know, is this game fair? So the minute I see the question asking me, is the game fair, I know that I'm going to be focusing on expected value. And so now we just need to think for a second about what do we mean by is the game fair? Well, as the person who's playing the game, I suppose I'd like to think that I'd win some money, and maybe I'd think that that was fair. If I was the person who was running the game, I'd like to think that I'd make more money than I'd have to pay out in winnings. So maybe I'd think that was fair. But actually what we mean by fairness and probability is when there's a balance between the two. And so what we're really looking for fairness is an expected value of 0. So I'll complete my table, I'll calculate my EX, and then I'll be able to make a decision about whether or not the game is fair based on that outcome. So if I get a 0 for my answer, yeah, the game is fair. And if I don't get a 0, well, even if it's positive or negative, that straight away means the game isn't fair. Okay, so I've made out my table. Down the side, I've just put my little guidelines in there about what my numerical outcomes on the dice are. But of course, don't forget, it's really the financial outcomes that I'm focusing on. And just while we're talking about those financial outcomes, okay, so if I roll a 1, I get nothing. But I have to take into account how much I paid to play the game. So I paid €2, so €2 is going out of my pocket. So really, when I roll a 1, I'm losing that €2. So the outcome when I roll 1 is that my €2 is lost. So if I roll a 1, the outcome is I lose 2, minus 2. If I roll a prime number, I get €1. Now, 2 is my first prime number. But remember again, I've paid €2 to play the game. So I might get €1, but I've paid 2. So on balance, I'm losing 1. And this will be the same for any prime numbers on my list. Now, if I roll a 6, I get €6. But again, don't forget that 2 that I paid at the start. So I might get €6, but I've paid 2. So really, I'm coming out with 4. And if I roll a 4, I get €2, which is just basically giving me back the €2 that I paid in the first place. So on balance, I have a net gain of 0. Okay, so now I need to work out the probabilities for each of these. Again, it's a dice, so the probability of each outcome is 1 in 6. And now I'll multiply each by the outcome, and these are my outcomes. And of course, then to find expected value, I have to add all of these together. So when I do that, I get a result of minus 1 over 6. Now again, I'm talking about money, so I'd rather write this in euro, and I'm rounding to the nearest cent. So in the long run, on average, I'm losing 17 cents. Okay, so the question was, is the game fair? Well, remember, the game is only fair if I get an expected value of 0. That doesn't happen here, so my conclusion is that the game is not fair.